All right, here we're looking at section 9.7, and our learning targets for today are first we're going to find areas of triangles. And you've been doing this in the past. We used our 1/2 base times height, but there's some other information that we may or may not have with those triangles, so we can use some of the information today to find areas of all triangles. Then we're going to be using the law of sines to solve some triangles and the law of cosines to solve triangles. And remember that when we're solving triangles, we are finding all three angles and all three side lengths. Here's our first example. So the first thing we want to do is we're still dealing with our trig function. So I want to use a calculator to find each trig ratio, right? So I can use my calculator and I'm trying to find the tangent of 150. So I can just type in 150 and then I'm using the tangent. So I know it would be a negative 0.577 and then I'm rounding to 4 decimal places. So this would be my 4th decimal place. So I always look to the 5th number, and since this is 5 or greater, I round this up to a 4. So that's what you'll see in this answer, is a negative 0.5774. So I would do the same thing for sine, put it in my calculator, and same thing with cosine. That's just our first step because we're going to be using these often this lesson. So to find the area of a triangle, okay, so the area of any triangle is, here are some of the things we're looking at. Okay, I want to talk to you about the big things. You're going to need to write all of these down in your notebook and put them somewhere where you can reference them. So I see that to find the area, I have 1/2 times 2 of my side lengths. So for here I have side length B and side length C. And you'll notice that again my side lengths are little letters and my angles are big. And the side across from the angle is how we're labeled. So you see that our 2 B's are across from each other, and the 2 A's are across from each other, and the 2 C's are across from each other. That's very important when labeling our triangles. So to find the area, I take 1/2 times the 2 sides that I have, and then I take the sine of the included angle, so the angle that's between them. So you'll see here I have 1/2 BC. So here's side length B and side length C, so then I know I would be dealing with sine A. So I have to have all 3 pieces, all 3 letters represented, but it's always going to be 2 sides and the angle in between them to find the area. So here's our first example of finding the area. So find the area of the triangle, round your answer to the nearest 10th. So I see I have 2 sides and I have the included angle, so that is something I can find the area of. So I use my equation, right? 1/2 times the product of the 2 sides times the sine of that angle. So then I just plug in the things that I know. I know my side lengths are 17 and 19 and the included angle was 135, and I just plug that into my calculator and then I end up with the area is 114.2. So the area of the triangle is about 114.2 square units. So here it's really important, since we're dealing with area, I have to use my units, and I know that area is squared units. So I can finish up my problem that way. So here are a couple that I want you to try. The first thing you always do when dealing with these triangles and finding areas is to draw out your triangle and make sure you have all of the information that you need. So now here's our law of sines. This was our second learning target, was using the law of sines. So again, I draw out my just generic triangle and label the sides and the angles. And here's the law of sines. I have the sine of angle A over the side length A equals the sine of angle B over the side length of B equals the sine of C over the side length C. You'll see that these ratios are all equal. The only thing that you need to know and care about is that all of the angles have to be on the top and all the sides on the bottom, or all of the sides on the top and all of the angles on the bottom. It really doesn't matter which way we go, as long as it's the same in all 3 that we're going to use. So now let's look at some examples of this. So here I'm asked to solve the triangle and then round decimal answers to the nearest 10th. Well, I've been solving right triangles, and here I see I do not have a right triangle because I have this other angle that's 115 degrees, so I cannot use my just normal trig values. So I'm going to have to either use law of sines or law of cosines. So we're going to use the law of sines, and we always want to start with law of sines because it's generally more simple to use. And I see that I have an angle and a side length that's opposite it. And whenever I see that I have those 2 things, I always want to use the law of sines. So now I can see that I have an angle and the side across from it. Now when I see I also have this side length, so I can use this side length to help me find angle B. So that's the first thing I'm going to be finding in this triangle. So I write out my law of sines, knowing that the sine of an angle over the side length is equal to the sine of the angle over the side length. Then I just substitute the things that I know. So the sine of B over 11 equals sine of 115 over 20. Then I multiply each side by 11 to get this out of the denominator. And so I'm left with sine B equals 11 sine 115 degrees over 20. So now I use my calculator. And remember from the last few sections, whenever I'm trying to find an angle, I always use the inverse sign. So let's go ahead and do this in my calculator. So I'm going to find the sine of 115 degrees, and then I'm going to multiply that times 11, and then I'm going to divide that by 20. So here you would get this 0.498 and la da 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 da. That doesn't seem like the actual measure of this angle B, and it's not. So here I'm going to use this information and I'm going to find the inverse sine of that. And now I end up with 29.9. So that gives me a much more realistic number. And since I'm finding the angle, I have to use the inverse to find that. Okay, so I know now that angle B is 29.9. So now I can find the angle C, right? Because I know that all of my angles added together is 180. So I just subtract 115 and that 29.9 from 180, and I get the angle C is 35.1. So now I can use my law of sines again to find side length C. So I've got the side length over the angle. Sine of the angle equals the side length over the sine of the angle. I plug in the things that I know. I multiply both sides by this sine of 35.1. So here now I'm just finding the side length, so I can just plug all this into my calculator. And I find that the length of C is approximately 12.7. So let's just look and see if that makes sense. So I see I have one side length of 20 and one side length of 11, so 12 something actually makes sense for this triangle. So I know I was correct. So now just to write out the final things that I found that angle B is 29.9, angle C is 35.1, and side length C is 12.7. So here I've used the law of sines and I just found the other angle by subtracting from 180. So now here are a couple I want you to try, and you're given different information in all of these, so see what you can do to solve the triangles. So now here's another example. So here I'm given two angles and one side length, whereas before I was given two side lengths and one angle. So I can follow my same steps and find the different side lengths and the missing angle. The first thing I would do is I would find my missing angle. Because I already have two of them, I subtract them from 180 and I see that angle A is equal to 48 degrees. Now I can go ahead and use my law of sines, and you can write them all out together. You don't have to, but you can. So I see that the side length A over the sine of that angle equals 15, which is the side length B over the sine of angle B, and side length C over the sine of 107. So now it's really, I have to write two equations. So I only have one variable in each. So I took this first part of my equation because I know this entire ratio. So I'm going to use this in both of my equations that I write. So I've got A over the sine of 48 equals 15 over the sine of 25. And then this one is helping me find side length of C. So then I go ahead and multiply and solve for each variable, right? So I multiply both sides by the sine of 48 here. And for C I have sine of 107. And then I use a calculator to find that my A value would be approximately 26.4 and C is approximately 33.9. So then I can just rewrite my answer. So I found angle A first, and then I also found the side lengths of A and C. All just using my law of sines and just finding that third angle by subtracting from 180. Now I can do this in any order, but I always want to find the easiest ones first that will help me then find the other missing information that I need. So now here's kind of a real world example. A surveyor makes a measurements shown to determine the length of a bridge to be built across this small lake. We're going to be building the bridge from North Picnic area to South Picnic area. So I need to find the length of the bridge. So I'm looking for side length C. So we always first have to figure out what am I looking for and how can I get there. So I see I'm given two angles, which means I can find the third angle, and then I can use that to help me figure out this missing side. So C, again, is what I'm trying to find. So first I want to find angle B, so I subtract the 71 and 60 from 180 and find that angle B is 49 degrees. So now I have angle B and I have side length B, so now I can use that and this angle C and the law of sines to help me find the missing value. At this point I don't really care what the length of A is, because this is not part of the question that I'm asking. So I just go ahead and write the law of sines using side length C and the other information that I have. multiply both side lengths by the sine of 60, and then I use my calculator to find that the bridge should be approximately 172.1 meters. So again, I find the information that I'm going to need in order to help me use the law of sines to find the final distance. So here are a couple more triangles that I want you to solve and see if you can do it when I'm given two angles and one side length. So now let's look at the law of cosines. This is our third and final learning target. So here's my law of cosines. This one's a little bit more complicated than the law of sines. So I see, again, I draw my generic triangle and label my angles and my sides. So there are three different possibilities for the law of cosines, just like there were for the law of sines. But here's what I want you to notice. The things that I notice when dealing with law of cosines is that the side lengths that are on this right side are not the angle that I'm using. So the side length that's over by itself on the left side of the equation is the angle that I'm dealing with. So here I've got the side a squared equals b squared plus c squared minus 2bc, these are the same side lengths here, times the cosine of angle A. So here this is just a little bit different. The only difference is I've got side length b over here, then I've got a and c and cosine of b. So my angle always has to match up with the side length that's over by itself on the left side. So if you can remember that, you don't have to remember all three parts, you just remember one of them and know that this angle has to match up with the side length that's by itself. So now let's go ahead and use the law of cosines. So here, I see I only have one angle, but I don't know the side length across from it. So I can't use the law of sines here because I don't have enough information. I would always end up with two variables if I wrote out the law of sines. So now I know I'm going to have to use the law of cosines. So I notice I have angle B, and B over here, it's the side length I'm missing. So I know that I'm going to be using that second law of cosines that we looked at because I'm dealing with finding side length B. Okay, so I go ahead and I write out my law of cosines, and then I substitute what I know. I know each of these side lengths, and I know the cosine of 34 degrees. Then I just simplify. So I end up with 317, right, because I can add these, minus, and then I'm multiplying all of these together. So I have to do this part first. And here, it's very important that you follow the order of operations, otherwise you will not get the correct answers. So then, once I have this a little more simplified, I take the square root, and I'm only dealing with positive square roots here because, again, I'm finding lengths, and I cannot have a negative side length. So I find the positive square root, and then I use my calculator to find that the side length of B is approximately 7.85. So now that I have the side length of B, now I have enough information to use the law of sines, which is a little more simple. So I can have the sine of A over A equals sine of B over B, substitute the things I know, multiply both sides, and then find this measure of that missing angle. So now that I have two angles, I can just use my triangle sum theorem and subtract those from 180 to find my final angle. So generally when we're using the law of cosines, we only have to use the law of cosines once because that will give us enough information to then go back and use the law of sines to help us find some more missing pieces. So here are a couple that I want you to try. And I notice, right, that I have two side lengths and an angle that's in between them. So I'm not able to use the law of sines here. So this is the other kind of triangle that I can use the law of cosines to help me solve for some information. So here I'm given all three side lengths and none of the angles. So I know I'm going to have to use the law of cosines. So I want to find this angle, and it really doesn't matter which angle I start with, I just pick one, right? So we're going to actually find the opposite of the longest side. So here's my longest side, so I'm going to be finding angle B here. So I'm going to use my law of cosines. So first I rewrite out my law of cosines, and then I substitute the things that I know. So here's where it's absolutely imperative and super important that you follow the order of operations or you will get the wrong answer. Okay, so I substitute the things that I know, and then I solve for the cosine of B. Right, so I would do my 27 squared. I would subtract both of these first. So minus 12 squared minus 20 squared, get those on the other side. And now that I'm multiplying, now I go ahead and divide. So we're always going to be following these same steps if I'm finding my angle. So now that I have the cosine of B all by itself on one side, now I can just go ahead and use my calculator. And remember, since I'm finding the angle, I have to use the inverse cosine. So I would do all of this and then find the inverse cosine of that value. So I end up with the measure of angle B is approximately 112.7 degrees. So now that I have one angle and my sides, now I can use the law of sines to help me find one of my other missing angles. So now I'm going to find angle A. So I'm going to use my law of sines, which is the sine of A over side A and the sine of B over the side of B, substituting what I know and what I found, multiplying both sides by 12, and then I just use my calculator. And again, since I'm finding an angle, I have to use the inverse sine here in my calculator. So now that I have found two of my angles, now I subtract them from 180 to help me find the third angle. So I was able to use the law of cosines and the law of sines to help me find all three of my angle measurements. So this is the other type of triangle that you can solve using the law of cosines. But again, we only have to use the law of cosines once, which helps us find the missing pieces. Then we can go ahead and use the law of sines to help us find the rest. So now here's our real-world problem using some of the same information. So I see an organism step angle is the measure of walking efficiency. So how far apart our feet are and can measure our efficiency. So the closer the step angle is to 180, the more efficiently the organism walked. The diagram shows a set of footprints for a dinosaur. So we're finding the step angle, so we want to find angle B right here. So I see I have a triangle and I have all three sides and I don't know any of the angles yet. So I know I'm going to have to be using the law of cosines. So I write out my law of cosines and I'm trying to find angle B. So here's the way it has to be written because the angle I'm looking for has to be the side length over here by itself. So then I substitute the things that I know, and now since I'm solving for this cosine of B, I would subtract both of these from both sides, then divide by this mess of numbers to find my cosine of B. And again, since I'm finding an angle here, I always want to use my inverse cosine in my calculator. So I know that the measure of angle B is approximately 127.3 degrees. So I've found this angle B. I don't have to find the other angles because I was only asked about this one. So now I'm done with this problem. Make sure that you're reading carefully what you're trying to find so you're not doing more work than you actually have to do. So here are a couple to try where you're given all three side lengths and none of the angles. See what you can do with these. So now let's double check our learning targets because we've looked at all of those examples. So first we were finding the area of triangles. And we can find the area of triangles, here with this formula, right? I take 1/2 times 2 sides times the sine of the angle that's in between. And that's true for any triangle. So I can find the area using that. Then I use the law of sines to solve triangles. And remember with the law of sines, it's very important that either all of the angles are on the top or all of the angles are on the bottom when we look at our ratios. And then our third learning target was to use the law of cosines. We use this law of cosines to help us find one more piece of the triangle, and then we would use the law of sines to solve the rest of it. So the big thing with law of cosines is to make sure that the side length and the angle that you're using are on opposite sides of the equal sign. So now that we've looked through these learning targets, go ahead and work on your homework for 9.7.